Good evening, ladies and gentlemen. Welcome to the Center for International Governance Innovation, or CIGI as we say. My name is Fred Kuntz. I'm the Vice President of Public Affairs here at CIGI. I'd like to thank our public event sponsor, Wordsworth Books, for their ongoing support of our signature lecture series. Thanks also to those joining us from around the world through our live webcast. Following this evening's address, we welcome questions from both audiences at the microphones here at CIGI and through the live chat function if you're watching on your screen at home. Please remember to state your name and to keep the questions brief. The topic of tonight's lecture is climate geoengineering. And what is climate geoengineering? Is it the solution to climate change, the techno-fix? Is it conservation ecology or the creation of a new Franken-climate or playing God? As the title of the address is the case for geoengineering, no doubt our speaker has a view he'd like us to share. David Keith comes to us from the Harvard Kennedy School, where he's a professor of public policy, as well as a Gordon McKay Professor of Applied Physics in the School of Engineering and Applied Sciences. He's Canadian-born. During his 25-year career, he's contributed to research on climate-related technology assessment and policy analysis, technology development physics, and atmospheric science. And these contributions have received recognition and even accolades from the Canadian Geographical Society, the City of Calgary, the Massachusetts Institute of Technology, Time Magazine, and the Canadian Association of Physicists. David currently splits his time between Cambridge, Massachusetts, and Calgary, where he's executive chairman of Carbon Engineering, a private company that proposes to capture CO2 from the air. And following the lecture tonight, David will be joined in a conversation on stage by Thomas Homer Dixon, CIGI Chair of Global Systems and Professor at the BSIA through the University of Waterloo. Thomas, better known to us as TAD, has recently been investigating societal innovation in response to economic, technological, and ecological change, and TAD will be facilitating this evening's discussion. So please join me in now welcoming Dr. David Keith.
Thank you very much. It's terrific to be here. I'm going to move this talk from starting in the most sort of specific, technocratic, kind of ugly way, giving you a specific idea about what we might actually do. And then move from there to talk more about what I think of it, what other people think of it, what enormous challenges it raises for global governance, what questions it raises for humanity's interaction with the natural world. Just before that, I'd say that kind of in answer to some of those implicit questions at the beginning, in some ways, I think the answer is all of the above. This is something that would result in Franken-planet. It is certainly not, though, a single unitary solution. There is no such thing as a single solution to a problem as complex as this. So let me start with this very, very narrow version of what one of the things one could do, one of the most plausible. So suppose you wanted to cut the rate of climate change in half, starting in, say, 2020. It turns out that on a technical basis, it is pretty clear that that is doable. And I'll say a little bit about how you could do it. So one of the most plausible ways is to put sulfuric acid droplets in the stratosphere. And what do those things do? They reflect away sunlight just the way droplets of water in clouds reflect away sunlight. Indeed, a droplet of water in the stratosphere would reflect away sunlight fine. The reason for the sulfuric acid is because the stratosphere is very dry, and if you put a water droplet, it would just evaporate. The other reason that people think about sulfuric acid is nature does this. There is already a lot of sulfur in the stratosphere, and big volcanoes occasionally put very large amounts of sulfur in the stratosphere and cool the planet down quite dramatically. That happened last in the early 90s with the eruption of the Pinatubo volcano. So to be really specific on a goal, and there's no right answer to what the goal is. There are some right and wrong answers about the science. I can tell you with some confidence if you do A, then B will happen. But the question of what the goal of such a program ought to be is fundamentally shaped by values and judgments and so on. So I'm not claiming this is the right answer. It's, to me, just a plausible answer. And it's a lot better than some really nutty answers that seem to be part of the mainstream debate. We'll get to that. So I'm saying the goal might be to cut the growth of radiative forcing, which is a big fancy word, which roughly means the amount that we're sort of pushing the climate, which has to do with the amount of carbon dioxide that's accumulated in the atmosphere. You could cut that in half starting in 2020. And doing that is frighteningly cheap. You could start in 2020 with roughly 2 or 3 aircraft. re-engine Gulfstream G650s. For those of you who like aircraft, there's lots of other things you could use, but we paid a big aerospace engineering firm to actually do a study, and that was one of the answers they came up with. And you'd start putting sulfuric acid in the stratosphere, and if you kept doing this all the way until, say, 2070, cutting the rate of climate change in half, and therefore cutting most climate impacts in half over that entire chunk of time, by the end you'd have maybe 50 aircraft or something. You'd be spending something like $1 billion a year, which might sound like a lot of money, but it's effectively zero when it comes to decisions about global climate. The costs of climate impacts, from everything from lost crop yields, from high temperatures that reduce the growth of crops during high temperature during germination, for example, or sea level rise or what have you, the estimated global costs of climate change mid-century are of order 1% of global GDP, so trillion-dollar numbers. And the costs of decarbonizing the economy, the costs of cutting emissions by switching to solar or nuclear or wind power, those costs are also of order trillion a year class if you want to actually decarbonize the economy by mid-century. So $1 billion a year is effectively zero. That's not a statement that it's necessarily the right thing to do, nor, and this is crucial, that it's a substitute for cutting emissions. So I'll say this several times during the talk because I don't want any of you to walk out thinking that I've said something different on this topic. In the long run, if you do not stop emitting carbon dioxide, you bring this climate further and further away from the stable or the metastable equilibrium that we had when humans first started to mess with it, and there is no way that any amount of solar geoengineering will fix that problem. So this is something that may reduce the risk, may very effectively reduce the risk, but with bringing itself lots of new risks in its train over the next, say, half century or century, but it does not perfectly substitute for cutting emissions. I mean, I guess to be glib, sulfur is not anti-CO2. It doesn't cancel out all the amount of CO2 that's accumulated since the Industrial Revolution. You can get carried away by the technological sleekness of this. So this is a picture of what one of those aircraft might look like, but underneath kind of sleek stuff and a kind of technocratic excitement about this, let's be clear, this is a very ugly technical fix. We're talking about putting a pollutant, arguably, in the stratosphere, one that would no doubt kill people on the ground from adding to fine particulate air pollution. The net effect, I think, would be very positive. That's what most models say, though it's not certain. But this is something that would be messing with the planet at a very large scale. We're adding essentially one pollutant to partially compensate away the bad effects of another. So that's the kind of a scheme we're talking about. There's several other schemes, but that's the core of it. And the questions that are really hard are all about how well it works, what the risks are, and most of all about who decides and how we decide to do it, or even to research it. One last comment before I get into the details. This is not a new idea, so this may be new to some of you. I'm one of the people who's been talking about it most prominently for a while, but this idea is absolutely not new. The very first major report on climate change that had all the science right, as we now understand it, that got to a world leader, got to President Johnson's desk when I was 2 years old, 1965. And it's actually worth reading that report because it's really nice and short. And now we have the IPCC report, which is this thick. I've been a member of the IPCC, but quit because it was too boring. It's a bureaucratic organization that produces these monsters. And the reports to Johnson, and if you look at the other reports, like the Energy and Climate Change report produced in the late 70s, they're gems of succinct, effective science policy analysis. And in that report to Johnson in 65, that was the beginning of really articulating the climate problem correctly to a world leader, saying that if we keep burning fossil fuels and putting CO2 in the atmosphere forever, we're going to have a very different climate. That report, as its sole suggested solution, had a version of this. So this idea is anything but new. And it was brought up in all the major reports in the 70s and 80s on climate change. But then it became taboo to talk about. As climate became a more potent political issue, many people on the advocacy side and on the science side felt that if they talked about this, people would lose the will to cut emissions. That basically by proposing this cheap, imperfect Band-Aid, that the ability to negotiate a deal to cut emissions would be lost, and therefore there was a kind of tacit agreement not to talk about it. Not a secret conspiracy pact, but just a kind of agreement not to deal with it. And only in the last 5 or 8 years has this suddenly come to the fore again. So The next set of slides I've given you are deliberately hand-drawn, both because my computer was stolen out of my house this weekend, but also because I want to emphasize, it's true, because I want to emphasize there's a lot of uncertainty here. And the hand-drawnness of some of this hopefully doesn't fool you by a beautiful computer model, which I'll show you at the end, that this is all precise. We're talking about the future of the world here, and the uncertainties are very large. So first, let's talk about carbon emissions. Don't worry about the units much, but the units on the y-axis there, gigatons a year, is the amount of carbon we're emitting. And while that's a hand sketch, it's roughly right. And the red line is the track we're on now, with very rapidly increasing carbon emissions globally. And that's not a lot of tragedy. That's partly because 100 billion people in China have lifted themselves out of poverty, but the consequences are this massive movement of carbon from deep underground to the atmosphere. Humanity is a geological force on the planet now because of that. And a geological force that dwarfs every other part of the carbon cycle. An obvious question you should have is to think, how big is our effect on carbon compared to nature? And the answer is the natural process that moves carbon from deep underground and puts it in the atmosphere is degassing of the crust through volcanoes, and we're like 100 times bigger. We're not a little perturbation on nature, we're 100 times bigger. That's why we're changing the climate at this extraordinary pace. So let's say we had a clean, green revolution. I'm including nuclear power, whatever. Let's say we have a combination of a policy revolution, because we're not close to that right now, and we actually manage to decarbonize the world's energy system pretty fast. And actually, that's pretty fast, that blue line, so that we bring emissions effectively to zero at the end of the century, and we peak them just before 2050. That is not an easy thing to do. That's sort of an aggressive strategy by the standards of people who analyze this. Let's say we do that. What does it do to the problem? Your natural assumption is it's kind of solving the problem. And for lots of pollutants, that would be true. So air pollution kills about 1 million or 2 million people globally, a lot from putting sulfur in the atmosphere. And if you stopped all emissions of that sulfur globally, the people would stop dying a few days later, because sulfur only lasts in the atmosphere for a few days. But carbon is not like that. Carbon lasts in the atmosphere like nuclear waste, millennia. So if you did that, this is what the plot of climate change would look like. So the x-axis here is this watts per square meter. Don't worry about what that means if you're not familiar with it, but just think about the x-axis basically being increasing climate risk. Basically, the x-axis has to do with the amount of CO2 that's accumulated in the atmosphere, and accumulation is the issue. The climate risk that we have this year, which we do have, doesn't come from the emissions this year. It comes from the emissions since the Industrial Revolution. We're adding fluid to a bucket, and it's building up. And when you stop emitting, all you do is stop adding to the problem. You don't make it go away. So this curve is what happens to the risk if you do this curve above. So you basically stop yourself adding to the problem, and then the risk stays about where it was for a while. That might be the right answer. There's no simple answer about what the right answer is, but that's one thing we could do. But it's important to say, because we're going to now talk about the technical fix, that this technical fix is not on top of doing nothing. This technical fix is on top of, in the example I'm going to give to you, really aggressive actions to cut emissions. And the point is, even under those aggressive actions, you're going to have pretty substantial climate change by the end of this century and even more the next. So let's say you do some solar geoengineering. There are various ways you could frame it, but I think it's important to think about it as something that's fundamentally temporary. I don't think you do it forever. You do it as a way to reduce the rate of climate change, to spread the climate change over a longer amount of time, because there is abundant evidence that a big chunk of the risk of climate change comes not from the absolute amount of change, but comes from the rate of change. And so we could use this technology with all its attendant risks potentially to reduce that rate of change. So if you did solar geoengineering along a trajectory like I've shown in red here, you'd start maybe in 2020, that was my first scenario, you'd build it up gradually to 2100 or something, and then you gradually ramp it back down to zero. And so the net effect of the climate risk and climate so-called radiative forcing would be what I've shown in orange there. So that's one scenario. But let's not fall into some kind of technocratic planner's dream. The reality is all sorts of things are uncertain here. It's uncertain how different nation states would act. It's uncertain what nature would do. It's uncertain what new things we find out. So one of the things that people worry about most in this business is that suddenly we'll stop. So that we sort of build ourselves this risk by committing ourselves to keep doing solar geoengineering once we've started. And I think some element of that is correct. So if you did it, in this case I've drawn it till 27.5, and then you suddenly stopped because there was a global war, because people forgot how to somehow keep the planes flying, because we found some particular risk of the geoengineering we didn't know about, that the particles we were putting in the air, caused some unexpected cancer or some really unexpected side effects. So we decide to stop suddenly. If you decide to stop suddenly, the climate warms suddenly. You reveal all the sort of latent warming that was there, and the impacts of that could be big. Of course, that's just one scenario. I'm going to throw more of these out there. Maybe what you do if you're a better manager is if you detect a problem with the sulfate system, you gradually ramp it down and you ramp up some other even better gee whiz engineered techno-fix, and just to be clear, we're actually working on these, that would not have an impact on ozone. And that's perfectly plausible. There are actual ideas that are pretty simple chemistry and physics that we're looking at right now that would in fact make more ozone, not less. Ozone loss is one of the risks here. But that again is sort of assuming a nice planning model and not new information. So another sort of scenario that could happen is, let's say it gets to be 2050 and we have some really new information that makes us take the climate problem much more seriously. And that could either be new physical information, like let's say the science and observations really convince us at that point that Greenland really is going to melt fast in, say, a century or so. And that's a lot. Greenland is like 6 meters of sea level. I mean, that changes the coastlines you see from space a lot. It like moves most of Florida. So if you found that out, you humanity, not everybody, because some people who are just a little more inland might make money. You've got to think about winners and losers. But humanity overall might get really worried and want to do much more. But another possibility is that this change doesn't come from new physical information, but just comes from a change in people's outlook. The whole question of climate change really comes down to how much one values the distant future and the natural world and people distant from you in space. If you cut emissions, cut carbon emissions, either personally or as a country, the benefits basically all go later in the century because of this long accumulation, and they go globally. And so the question of how much you care about that is a question that goes really to the core of kind of social values. There's no easy technical answer for it. And it's quite possible that we'll have some revolution in those social values that changes that in some fundamental way, so that people are much more willing to make real commitments to cut emissions. So maybe you do that. Either of those things could happen. And of course, you can think of horrifying things too. And then maybe you do something like this. So you actually start activities to remove carbon. I won't talk about them much, but there's a whole series of ways one could actually engineer more carbon sinks. And also you could spend much more effort cutting emissions more quickly. And then maybe you do more solar geoengineering, so you really reduce the total climate change in order to, say, cool Greenland down. Or maybe you do less. The point here is simply that this is highly contingent, and it's not as if we have one clear trajectory where we know what's going to happen. So coming back to this is an opening scenario, but I think the key is that it's a moderate scenario. This may not seem very moderate to you, but it's moderate in the sense that I'm not advocating that we would compensate away all of the climate damages from this, only about half of them. And I think that's important for lots of reasons, some of which I can get into in questions, but a key one is that we still want to have there be some real benefits from cutting emissions. The second thing is that it be responsive, that we have this thing be able to react to new information. Those are really the two key. So that's still a kind of technocratic talk. I've been talking as if there was some magic central planner. And I think it's fair to say, not every scientist would agree with this, but most, that if we actually had some democratic, globally representative system where there were a panel of experts that really represented the world's values, and they had time to think and plan and do calculations, and they were entrusted with decisions about how to use this technology, that almost for certain this technology would be a benefit. I mean, if it's risky, you just don't use it, and if it provides real benefits, they use it in an amount that provides the benefit. And it really does look like it could substantially reduce climate change in most of the world. I haven't really said that. I'm happy to say it in response to questions, but essentially every climate model we've run now suggests that if you do this, you can reduce not just temperatures, but the change in precipitation, the change in many other climate parameters we care about in most places in the world with attendant risks. So that's true if we have some kind of global group of wise men and women making these decisions, maybe wise polar bears. But that's not what we have. And in the real world, I think there are all sorts of ways that the outcome of this technology could be horrific. But those ways are mostly, from my point of view, not kind of technical gotchas. Not that there aren't technical gotchas, there are, and we worry about them. but they're gotchas that have to do with giving a very powerful, fast-reacting technology that essentially any nation in the world could use. I showed you that fancy business jet. This is not something that can be just built by the U.S. in the form of Lockheed Martin or other major powers, but Embraer Aircraft of Brazil or Hindustani Aeronautics could easily supply the necessary hardware. So essentially, any country with money is potentially in a position to alter the world's climate radically using these methods and fast. And that's a very dangerous thing given the unstable geopolitical situation that we find ourselves in. So I want to start talking about how people react to this idea. So this is reactions from several thoughtful people and fellow Canadians about this topic. And a bunch of these are up to date. So the one from Al Gore is up to date of just a week or two ago. Insane, utterly mad, and delusional in the extreme. And I've talked to him about this, so it's not like he hasn't talked to some people who at least believe that they're sane. And he specifically in that phone call called out how scientists who imagine this could in any way be helpful are just completely deluded, which is a pretty strong statement from somebody who thinks seriously about climate risk and knows it. I'd like to dig into a little bit about why people think this, because I think it reveals something maybe about their judgments about the risks, although to be blunt, I doubt it, because a large number of climate scientists who really looked at this don't share this view about the risks, including now even the IPCC. I think what it reveals is people's judgments about what kind of answer they want and what kind of social answer they want that actually has very little to do with climate change. So I'll pick a little bit on Naomi Klein. This is a longer quote from a piece she wrote about climate change where she said, real solutions are ones that steer these interventions to disperse and devolve power, to control community level, renewable energy, local organic agriculture, transit systems accountable to their users. Well, I buy community-supported agriculture, and I like organic farming. But the actual evidence, I don't do it because of climate. I do it because I like the community engagement. The actual evidence that, for example, some of these things cut emissions is essentially zero. So if you actually do serious life cycle analysis of whether, for example, the 100-mile diet has less emissions implications than a longer diet, the answer is a wash. Depends on the details, but long-distance transport is not a big contributor to emissions. So there's an enormous amount of stuff that, to be honest, in the kind of green left is just disconnected from facts on this. And I think what it reveals is that Naomi has a pretty clear idea of what kind of social change she'd like, and in fact, I actually mostly agree with it. But she's not really connecting it with climate change in an intellectually serious way. She's just using climate change as a stick, a fear factor, to try and push people to do what she'd like to do for completely other reasons. So I think she's not working from the problem to solutions, but precisely the other way around. And I think that's deep here. People have a set of ideas about what the root cause is that has to do with how they like to see society transformed, and that shapes their views about climate and what we should do about it. Here's another way to say the same thing and guess this issue about what the root cause is. So this is a statement from this group called ETC, one of the most effective lobby groups against people like me talking about geoengineering. And I would say this statement is true. I don't argue with it as written. It's certainly true that this does nothing to change the amount of CO2, and at some level, symptoms are addressed, not causes. But it's not clear that I don't draw the same conclusion that ETC does from that, even though I agree with the statement. So, I mean, true, but stopping the transmission of flu virus does nothing to change the rate at which new strains emerge from contacts between pigs and poultry and people. But we don't have a big ethical worry about that. We're happy if we just slow down the rate of flu virus so less people get sick. And people don't get upset about the fact that we're not somehow solving the root problem. And what is the root problem anyway? Is it just that there are people? Is it that we have pigs? What is the problem? There's no easy way to define the root problems. Slowing down or stopping CO2 emissions using huge wind power doesn't change the control of the energy industry by corporations if that happens to be a problem that bugs you. So symptoms are addressed, not causes. Slowing down or stopping the rate of warming by solar radiation management, or this solar geoengineering, does nothing to change the factors that drive our species to go right to the limit of the carrying capacity of the planet. So symptoms are addressed, not causes. I think that's a fair statement. So I think at some level, technology expands the bottle into which human desire fills, like a gas. And when we add new technology, whether it was agriculture 10,000 years ago, or modern computers, or access to oil, we expand the potential living standards and range of consumption that humans could do, and they push to the edge. And that's been happening not just in recent industrial civilization, but that's happened really since there were humans. I mean, and humans' ability to shape and destroy parts of the natural world go back way before industrialization, to, for example, when humans first got to Australia and wiped out most of the species bigger than that. So I think this idea that there is a single root cause is just wrong. And what it really does is tells each of us, when you think about what you think the root cause is, something about what you care about. But it's not an objective statement. So here's another way to think about some of the reasons that, that people often don't like this, and not to say everybody doesn't like it. And some of these I think are very wise. One of them is this is a classic end-of-pipe technology. And there are at least some industries where we've had great success moving away from that mode of fixing problems. So this is most true in the chemical industry, where it used to be, say in the 50s, that the conventional thing is if you had a chemical plant that made some evil toxic chemical as a byproduct, you would pay somebody to build a scrubber to try and remove that plant, or maybe you just dilute it, put more of it in the water. And increasingly, we realized all the ways that that could fail, you know, that your machine for scrubbing the toxin can easily break when it's out. And so in the chemical industry, there's been a real wonderful kind of global revolution, not perfect, of green chemistry to try and focus on changing the core process so we don't make the ugly product. So then you don't have to have an end-of-pipe cleanup. You've changed the process. And I think there's no question that when you can do that, that's the right answer. And if I thought there was some magic way to do that for climate change, I'd be all for it. I agree that end-of-pipe solutions are inherently things you should be skeptical of. It's just that we don't seem to have any easy, deep process solution for this. Another one is people's often stated bias that we should have a social solutions, not technical. I'm not sure that stands up under scrutiny the more you think about it. I'll leave that for questions. What I think you can say is that despite all the talk about reduced consumption and about different ways recently to sort of bottom-up consumer behavior might change things, if you think about the really big environmental wins in the rich countries since the war, managing air pollution, not perfectly, but substantially, managing toxic metals like lead and mercury, managing DDT, the global ozone problem, in all of those cases, I would submit the fundamental deal was technical fixes. Now, those technical fixes didn't just happen magically. They required environmentalists to fight and to push through legislation, which eventually had to push industry to do things it did not originally want to do at all. So this didn't just happen by kind of magic happenstance. People had to fight hard. But we didn't solve these problems or partially solve them by just driving less. In fact, we drive much more than we did in the 50s. But we put on a bunch of catalytic converters and other controls on cars, for example, so that cars, for some pollutants, emit 1% of what they did when I was a boy. Global, not local, you can argue this both ways. And this is a funny thing about the kind of arguments you get from folks like Naomi Klein, because of course, solving problems like climate change, almost by definition, cannot happen at a local level. This is a coordination problem. Forget geoengineering. If you just want to cut emissions, the problem involves this coordination and involves essentially, in some way, increasing the power of a global sovereign to solve these problems. Not that we have some magic alien come from above, but we need to find ways to manage these global public goods problems, and that's not done by devolving power locally, I believe. I think there are serious issues about control of nature, about the fact that while you may start doing this as a way, perhaps rationally and sensibly, to reduce climate risk, once you go down the road of developing technologies to deliberately alter the climate, I think you're almost inevitably committed to at least getting to the question of what you want the climate to be, of getting the question of how you might engineer the climate, not just to reduce our impact on climate, but to engineer the climate in a way that humans might prefer. And then, of course, you say which humans and humans living in which generation. But I think this does get us towards Franken planet, for good or for worse. And you really can make arguments in both directions. I think it does mean the end of nature in some way, as Bill McKibben wrote, but I think it's also true that forcing us to be honest about the fact that we are at some level in the gardening business with this planet might force us to take more responsibility for our actions. I'll get to the moral hazard one later. And it's fundamentally a short-term fix, but that is both a plus and a minus. Back to this one about control of nature. This is a quote I keep using, because I just think he really nailed it. Tom Schelling is one of the most thoughtful policy advisors on this topic. He's advised governments on these topics since the 60s. And he said in the 1982 National Academy report, interest in CO2 may generate or reinforce a lasting interest in national and international means of climate and weather modification, what we're now calling solar geoengineering mostly. And once generated, the interest may flourish independent of whatever is done about CO2. And I think that's a realistic worry. So if you hired me, and I wouldn't take the job, just to be clear, to maximize global biospheric productivity, the amount that plants grow globally, I would not aim to bring the climate back to the pre-industrial. I would aim to have a lot more CO2 in the atmosphere, and then to do some of the solar radiation management to flatten out the pole to equator gradient and make the climate more the way it was in the Cambrian. And we know we had much higher productivity then. And so if you're the kind of biologist who says the goal here is to maximize biological productivity, be careful what you wish for. There's a technocratic answer. So, and it's not an answer I support, to be clear. I would like us to keep nature more the way it was, but that's a value judgment. It's not a necessity statement. I'll end here. This is a Tolles quote that I think just nails it. It says, the year is 2060, search for a breakthrough technology continues. This is a time machine. Take us back 50 years till we should have put a price on carbon. And the guy, one of the little guys at the bottom says, oh, we gotta hurry up, we gotta hurry up. But of course, we don't have to hurry up. It's a time machine. And I think that's exactly the sort of the underlying fear, the sensible fear, or one of the sensible fears about this technology, is this kind of aspect that just allows us to delay and put off doing anything because we have this time machine. And it really does have time machine aspects. So if you think about one of those things I showed you at the front where CO2 concentrations just keep rising, so as time goes forward, the CO2 concentration just goes up as you emit more, this allows you to partly go backwards. And in that time machine aspect, it presents exactly the kind of risk that this gets at. Thank you very much.
Thank you so much, David. This topic evokes very powerful emotions. And I think it makes us think fundamentally about who we are as individuals and as a species. And I've always been surprised and intrigued by the nature of the emotions that it evokes. So you've touched on some of this in a way that you didn't when you did your presentation at the school today. And I think that's very interesting. It scares people. And I think folks, many folks in this audience probably find this scary. The question that is in the back of our mind is, what have we done? I can remember at a meeting that we attended many years ago, you helped organize, that one of the senior climate scientists got up and said, the fact that we're even having this conversation is evidence of a colossal moral failure on the part of humankind. So you've talked about some of this. You talked about how it evokes our attitudes towards nature, but it strikes me that there's more. You often hear it encapsulated in this idea that we're playing God, and there's something profoundly hubristic about what we're proposing to do here. And is that really the source of the emotional reaction? That, as you sort of suggested, once we go down this road, there's no stopping. And it opens up possibilities not only for changing the natural world, less and less natural world around us, but for changing who we are in a very fundamental way.
Let me first take the comment that it represents a huge moral failure that we're here. I used to kind of say that easily, and there are several kind of glib comments that people like to make about this, like it's a bad idea whose time has come. But the more I think about these things, the less willing I am to say them. I don't think this represents a huge moral failure. The fact that we're living in a technological civilization with a lot of CO2 in the air, at least for most of the long history, represents an unattended side effect. People who began to mine for fossil fuels and drill for them, this stretches back 1,000 years and accelerated 100 years ago. did not understand this consequence. And to the extent that they did understand that there were some big trade-offs, these trade-offs are not simple. And we have to be very careful about sitting in a wealthy group of people in a wealthy auditorium, wringing our hands and lamenting when there are 1 billion people unserved by electricity. And we have to really think hard about these trade-offs, both in this generation and future. So I'm not so sure it represents a huge moral failure in the same way. But to get to the main heart of your question about hubris and the sort of horrifying nature of controlling the natural world, I do think that's a big part of it. I mean, of course, part of it is actually very sensible concern that there is no single global actor, and that even if people like me are partly right that done in a particular wise technocratic way it actually might work, that there are all sorts of ways that they misused, and so people believe that there should be none of it. And I think that's actually a quite defensible and perhaps correct position. I sometimes wake up in the morning wondering whether I ever should have started talking about this. But still, beyond that, beyond the kind of political fear that it will be misused, I do think you're right. This forces people to think about what the goal is and what the natural world is, and in ways that challenge us. And the way I've thought about it the most is the way that it challenges a tendency that I think is come part of the environmental movement to be very technocratic. So nowadays, in the environmental movement, people increasingly feel that when they speak to power, they have to do so only in technocratic terms. So if you have scientists who's worked on rainforests their whole career, and they go to speak to Congress or Parliament to defend the rainforests, typically nowadays they'll talk about ecosystem services and carbon holding and a bunch of stuff like that are all kind of narrowly defined technical terms. And it is absolutely not what they really think. And an easy thought experiment reveals it. If they talk about carbon holding and I come along and say, oh, I've got a machine that holds carbon twice as well as rainforest, are you going to be overjoyed that I cut the rainforest down and replace it with my machines? Of course not. Mm-hmm. Because the reason the person actually cares about the rainforest is just that they love it. And it's not the technocratic reasons at all. And I think we need to be more, the environmental community needs to be more blunt about talking about that. And I think that's actually centrally true for climate change. I think that the climate community's attempted, or the environmental community, to make the case for acting on climate change, forget geoengineering for a second, on a kind of technocratic cost-benefit grounds, and it just ain't working. And I think maybe we'll lose the fight to cut emissions no matter what. I've spent a lot of my career working on that, but I'd rather lose that fight fighting on what I really care about. And what I really care about is, at least significantly, that I'd prefer to leave part of the natural world that I love more the way it was for my kids, not because it has some big ecosystem value that I can quantify, just because I like it, and a lot of other people do too.
So that touches on something that I think is really profound, because and we're finding increasingly that one of the things that is deeply disturbing about climate change for folks around the world is the sense of loss of things that they regard as kind of subtle symbols or signifiers of their environment. When the songbirds come, the monarchs, when the trees change and the colors of the trees in the fall, and people notice that something's different. And as these environments change, they feel like they're losing their connection with something that has actually made them, that grounded them in their natural reality. And it seems to me that what we're talking about with geoengineering is stepping across a boundary where we're acknowledging we have lost an enormous range of what it had meant previously to be a human in a natural world.
So yeah, but it really depends on which side of the fence between humanity and nature you're on, in a way. Because of course, from the point of view of nature, not that there is any simple point of view, we're already modifying the world hugely, and the fact that we've done it mostly unintentionally hardly matters. And if this solar geoengineering technology, just assume for a second, actually works the way I said it would, to be clear, we're not clear about that. We need to test. I'm not actually advocating doing it right now. But assume it actually does reduce the risk. From the fact that it's intentional and the other part wasn't, is sort of irrelevant in terms of the impact on the natural world. So I think both things can be true. Technologies like this might actually reduce the impacts on the natural world in ways that were good. But at the same time, it's true that in some ways they make the natural world not natural anyway. They make it an artifact. That's right. In the sense that when you see, I've spent a bunch of time traveling. I do self-supported ski trips in the high Arctic, like on North Baffin Island. And if you travel in places like that where there are very few humans, what you see around you is worlds that was not shaped by us, a world that was shaped by natural processes over millennia. And nowadays, when you think about why that world is there, I'm not religious, but you think about it in ways that aren't to do with why somebody wanted it. But if I think about this water glass, it's an artifact. And so I think about the cultural and technological combinations of things that made the water glass the way it is, but it's not a natural thing. And I think the day you begin to manipulate the global climate that way, at some level the world becomes more of an artifact, because the reason that the climate or weather, if we modify that, is then what it is because somebody decided to make it that way. It's a political decision. But again, that line isn't black and white. So that was before we knew about climate change. But as I said, we've sort of known about this since the 1960s, arguably. And at this point, we're doing it knowingly.
That's right.
So at some level, we are making a de facto political decision that we're happy to have a climate with more CO2 in it.
Right, exactly. So one thing you talked about this afternoon, which you didn't mention much this evening, is the distributional impacts potentially around the world. And you made up some very important points this afternoon that I think would be worth the audience hearing about the surprising findings regarding distributional impacts. It's the buzz out there is with geoengineering, it's going to have huge negative impacts in some parts of the world, for instance on precipitation, and more benign impacts in other parts of the world, perhaps even beneficial. But you found something different, and then maybe you can just elaborate on that.
Maybe I'll say a simple version first. So it's a pretty simple physical fact that's true in every model, and there's basic physics that says it, that the precipitation responds more quickly than temperature to this solar forcing. So if you increase the solar forcing, let's say, to restore global temperatures to the pre-industrial, then precipitation, the global rainfall rate, would be less than pre-industrial. That's a true statement, but it's an equally true scientific statement to say if you brought precipitation back to the pre-industrial, temperature would be above. And from a scientific point of view, those are equally true statements. It's just a ratio. But in terms of the political debate about this, if you Google it, you'll find almost half of all the Google hits are about the fact that this will cause droughts in India, which come from a particular assumption that we're going to kind of overdo it, put so much geoengineering in that we restore temperatures, which should be nuts and nobody's advocating, in a way that then cuts precipitation. And that's become part of the political battle about this, where people then use this saying it's a feature of this technology that it cuts precipitation, which is simply false, in that if you do enough of this technology so it makes precipitation, it stops the increase in precipitation, then it hasn't cut it. It's actually reduced the impact of increased precipitation, which is real. So that may sound a little bit complicated, but this is partly a scientific battle about framing. And I guess one other comment is, maybe I'll tell a story about how this began. So back 15 years or so ago, Lowell Wood, who was an advocate of thinking about this and a leading nuclear weapons decider, a very unusual person, he gave a talk, he likes baiting liberals, which I was at, where he said how perfectly geoengineering would work. And myself and a friend called Ken Caldera, another Canadian Backlash Meal, all stood up in the back of the audience and said, Lowell, you don't know what you're talking about. The top of the atmosphere physics of the way this works means that it won't work very well. The compensation won't be good. At that point, there was no climate models run. And Ken Caldera, one of the people who's now become a leader here, went back to his lab to run a model to prove how Lowell was wrong. And in fact, the model showed the compensation was very good, and that Lowell was at least partly right. And subsequent models have borne that out. So I and several other investigators have now done pretty careful things where we look region by region, in quite small regions, and using many different models to understand how effective this is on a regional basis of restoring not just temperature, but other aspects of climate. And it's not perfect, but it's surprisingly good. It works much better on a region by region basis than we thought in models. How well it works in reality, we have no way to know.
Mm-hmm. I have one more question, but I just want to let folks know that if there are questions from the audience, I'd ask you to go to the two microphones. There's one on each side. And in a moment, David will start recognizing folks from the microphones. Or I'll keep asking questions, but I would expect that there will be quite a few from the audience. And please introduce yourself with your name and make it a question, not a comment. And we'll continue with the conversation with the audience. So, David, this is a $64,000 question.
So where do I get the $64,000?
It's 2050. And you may say this is an impossible question to answer, but it's 2050. Given the way you see the trajectory of emissions and political response and social response to this problem, do you think we're going to be geoengineering on a major scale at that point?
I think there's a good chance that we will be, but I think you can imagine circumstances where we don't. So I do think you can imagine stable political outcomes where we don't do it. And those outcomes might well be pretty good versions of the world, I think. So I don't think it's guaranteed, but I think it's likely we will. But I think it's extremely hard to guess, partly because this thing is just coming out of the box. So I happen to have been somebody who's thought about this back to the late 80s when Tad and I, in fact, met and talked about it. But it was a tiny in-clique. The geo-nerds, as we're sometimes been called. And it's still a pretty small clique, partly because the taboo has been so strong there's not really much publicly funded research. It's just changing now. So this really hasn't been opened out, or it's just opening out now to bring more voices in outside the scientific community and from different countries and political backgrounds. And so only now we're starting to get a wide debate. I think it's very hard to say where that debate lands. But I guess the bottom line is I'm somebody who certainly had a role in kind of opening the door to having this be publicly talked about. And there are some people who argue that we need a geoengineering Manhattan project and we should go ahead full steam for all sorts of reasons. But in fact, even though I'm somebody who's pushed to open that door, I'm frankly more worried that the door will be slammed open and people will stampede through and we're going to rush very quickly to do this in foolish ways.
Now, you said something important that I think perhaps some people overlooked, that the principal role, as you see it, of this technology is to slow the rate of climate change. So the implication there is that we will actually get to a certain degree of climate change when the climate reaches equilibrium at some point in the future. But we want to make the trajectory of getting to that equilibrium point a lesser slope, I guess you could say. Now, some people might think that, well, that's a pretty grim outcome. Because if it's 4 degrees or 3 degrees, 4 degrees, it's going to be catastrophic whether it's 2300 versus, say, 2150. Now, I know that you're involved, and I think it was probably mentioned in the bio, that you're involved in another kind of project, which could also be coupled with this kind of solar radiation management, where you provide some slowing of the warming while you undertake globally a transition in energy technologies to low or zero carbon energy technologies, and simultaneously you start taking carbon out of the atmosphere. So I was wondering if you could say just a little bit about what you think the prospects are for air capture, because that's another kind of, in a sense, geoengineering. And I think in some sense the solar radiation management might be much more palatable for people if it were coupled with an explicit commitment to air capture. Okay, we're going to have to do this for a while, folks, so we don't melt Greenland and Antarctica. And in the meantime, we're going to really try to ramp back to 350.
So this is complicated because it gets into a bunch of conflict of interest questions, and I was sort of hoping you wouldn't go there, but I'm happy to give it a shot. So one of my other hats is that I run a startup company that's trying to develop technologies for capturing CO2 from the air. But we do not in any way think of ourselves as geoengineering. We think my involvement in geoengineering is just harmful to the company and try and avoid this conversation. That's one of the reasons that we have a CEO and are trying to get me out.
Well, let's not call it geoengineering.
But it matters. I mean, so our company, you brought it up, and I got to put my company hat on and say, we are trying to make low carbon transportation fuels in the near future to make money. So we think we can assist working with either algal biofuel companies or oil companies. We have ways to make transportation fuels, like liquid fuels like gasoline, that have very low well-to-wheel carbon intensity, lower than any biofuels. And under existing, I think there's a pathway to actually be profitable in the near term doing that. And we see ourselves as competing against electric vehicles and some other kinds of biofuels, but we do not see ourselves as a small company in any way trying to manage the global climate. And I mean, a key thing to say is until global emissions are zero, there's no difference from nature's point of view or from the climate's point of view of not emitting a ton versus emitting a ton and recapturing it. They're the same thing from the point of view of the balance. So we see our competition as entirely other ways to cut emissions, and we think we're competitive in a particular part of the transportation sector in that regard.
Now,
and so companies have short time horizons, right? We want to actually succeed in building real hardware, $100 million of hardware over the next 5 years. What happens 50 years or 75 years out when we might want to have emissions be zero, our company, I'm sure, doesn't exist, and the patents that expired, and this is another world. So I just want to really separate these things. Partly because there's been enormous and well-founded attention on the idea that there shouldn't be commercial activity in solar geoengineering, and I actually completely agree with that and support it, and none of the work I do on solar geoengineering is in any way commercial. So they're very, very different things. So long-winded answer, but I sort of feel like I have to do that.
Yep.
So air capture, this idea of capturing CO2 directly from the atmosphere by technological means like my company Carbon Engineering works on, is just one of many ways you might make negative emissions, and it's probably a comparatively high-cost way. But I think broadly Tad is correct, that what I didn't say much in that scenario, just briefly, is that if you whatever you do to gradually stop emissions, at some point you have a certain amount of CO2 in the air. And you might decide that in fact you can tolerate that much CO2 in the air. But you might decide, and again, there's no single decision maker, that that's really too risky and we want to reduce it faster than the natural processes do, which are extremely slow, 1,000-year timescales. And there are certainly ways to do that, and some ways that are quite doable, now, meaning the next 30 or 40 years at scale. So for example, some of you may have heard about CO2 capture and storage. If you do that using not coal, but using biofuels, then you have a net negative transfer of CO2 from the atmosphere to underground, and there are quite a lot of other ways of which air capture is just one. And I think broadly, it could be done. But it's important to say it's not a near-term competitor. That only becomes relevant once you've reduced emissions greatly.
Right, fair enough. So we're really talking about the possibility of some solar radiation management, radical and aggressive attempts on mitigation of emissions, and perhaps further down the road, large-scale air capture.
And other ways to do negative emissions. But I mean, some of the same gotchas apply. So Josh Stolaroff, one of the first grad students that worked on what eventually became that company, Josh he was a California hippie, and he was very concerned, and I share that fear, that he was sort of making the world safe for SUVs, that if we had a way to really make real carbon neutral fuel like this, then we made the world safe for SUVs. And at some answer, the technocratic answer is, so what? Yeah. There are other issues with SUVs. Our job is to try and reduce the climate risk, and if we have a way to do that, great.
Mm-hmm. Okay, well, with that provocative statement, are there some folks at the microphones here? I'm going to pull out my BlackBerry, Jim, but I'm doing this so that I can check the time and keep an eye on the time as we go through our questions here. Hold on.
So am I selecting questioners, or?
Well, I think it's going to be pretty straightforward. I don't see a long lineup at these microphones.
You agree with everything I said, or it was so transparent? I mean, these don't have to be questions. Actually, on this topic, I'm personally happy to have things that just say a short statement about, if you happen to think this is just nuts, a short statement about why, not a long one, that isn't a question. I'm perfectly happy with.
There's a microphone here, so let's start here. I see, so I was looking further up the stairs. So let's start over there, and then we'll alternate back and forth, so go ahead.
Thank you very much for your talk. To the extent that I understand it, I'm wondering if you could factor in demographic projections, because some demographic projections say that by about 2050, those of us who are baby boomers and et cetera will die off in massive numbers, and the world's population will dramatically drop. Of course, this is projections.
If we have a big war?
No, as development and education expand and people rise out of poverty, they have less kids.
Oh, fertility rates drop that fast?
Have you factored in demographic projections into your climate change projections out to 2100?
I'd say that demographics tend to be one of the slowest changing and most inertial parts of it. So when one thinks about projecting emissions out to late in this century, most people think the really big uncertainties are all about the extent to which the poorest few billion get richer and the changing energy mix. And unless fertility changes just enormously, or we really do have a big war, it's hard to get very much change in population, because it turns out that it's a very, I'm using the physicist wording, but it's a very inertial system. Like if you make changes to the fertility rate, or if changes in the fertility rate happen, it takes a long time for that to propagate through the age structure. And what we've seen is a global, extraordinary collapse in fertility rates. I guess I'll say one thing, which is that I noticed there's a lot of demographers and thinkers on this topic who all post facto say confidently that, sort of as you just implied, that wealth and changing culture automatically means that fertility rates go down. But they didn't make those projections beforehand. And I think the answer is we truly don't understand very well all the factors that have made roughly half the less kids than replacement, because roughly the richest half of the world now has fertility rates of 2 or below. And we don't really understand why. And that means it's completely plausible that the opposite will happen, that people will decide to have more children. So I think that there certainly is, it's fair to say, deep uncertainty about that fertility rate, but less uncertainty about the population because of this long inertia.
Just to extend David's point, in the last 10 years, it's been interesting to watch the United Nations projections of median population peak, median projections of population peak later this century. And about 10 or 15 years ago, it was around 8 billion, 8.2 billion people, 2050, 2060, and now it's crept up to 9, 9.5, 10. So actually, we're somewhat more pessimistic now on peak population on the planet than we were 15 years ago or so. But it's quite possible towards the end of the century we will start to see the kind of decline you're talking about. But it's a long way in the
But in terms of emissions, that's not a big impact, because that's like 20 to 30% change in population compared to now. And people, right, you could easily get factors of 3 change in emissions. I mean, if the poorest billions keep getting rich the way people in China did, it's possible to have emissions triple.
Let's take the question on the screen there, right in front of you, David. What form do you think public participation in climate geoengineering decisions and debates should take?
I'm going to try to give a quick answer. I mean, obviously, it's sort of an infinite answer, but I mean, one fundamental answer is getting governments involved, because ultimately that's the expression of democratic governments, or some expression of how political participation happens and I think should happen. But I do think there's a role for things outside governments, for ways to get the public involved relatively early in decisions about how to steer research and about research governance. And there are quite a few activities, including some that I've been involved in, that have tried to do that. They try to involve selected groups of public early to get their input about what we should do. Because I think the one key thing to say is this is fundamentally a design problem, an engineering problem. And engineers, sort of by definition, are solving a problem. So we didn't invent the BlackBerry, the iPhone, because we kind of discovered it in digging away. People had a problem they wanted to solve, a way they wanted to make money, and they figured out how to assemble a supply chain and do innovation to make it happen. And that's sort of the way engineering works. And this is the same. There are lots of ways we could learn how to manage the global climate. And technocrats or innovators always have some idea of the problem we're trying to solve. And that idea, in, say, my mind or the minds of other people like me, is particular to our culture and so on. And there's no right answer there. And in my opinion, I can help figure out ways we could do this. But the decision about what the goal is, what we're trying to do, my value should count no more than anybody else's. And so I think it's quite important to figure out how to get the general public to weigh in on what the end goal is, what we're trying to do.
Do you know of any exercises in the world right now where the public is being actively consulted on geoengineering?
Oh, yeah. Yes, is the short answer. Several. Mm-hmm. I mean, in fact, as funding has gradually started from governments, there's now several European projects totaling many tens of millions, well, 10 million class in total. Almost all of those have been weighted heavily towards the social science. So in the programs in Germany and Britain, there's quite a few of those, and we've had some that we've run out of the program at Carnegie Mellon.
Mm-hmm.
Yeah.
Let's go over here.
My name is Alan Whiteside. I'm a recently appointed CIGI Chair in Global Health Policy. The most interesting thing I read today was Bill and Melinda Gates' annual letter ahead of Davos, which is optimistic, looking at health and development. So your pessimistic view of, or your realistic view of the world, are you being listened to by people outside of Washington, London, Paris, and Ottawa, and of course Waterloo?
Hard for me to judge. I mean, as you know, if you Google, I'm one of a couple of people who are sort of Bill Gates' kitchen cabinet for some energy and environmental topics, so certainly I help bring people to talk to him. But he has many advisors. It's not for me to judge. I have no idea is the answer.
Hello, I'm Gordon McBain. I hold a variety of hats, but let me say I'm the chair of the Canadian Climate Forum, and we had David as a speaker at one of our events 5 or 6 years. We had a different name then, but you were there. And we're going to have another event in April, so you can join us
But
then.
we had the same names.
Yeah. Anyway, I'm also the president-elect of the International Council for Science. And I had two questions. One, I was thinking of all the way through until right near the end when you partially answered it, but you have chosen to define geoengineering as strictly and only as solar engineering, at least in your presentation, which is contrary to what myself and most climate scientists think, because we include carbon capture, carbon reductions, iron fertilization of the oceans, etc. So I guess one of the questions I'd like to ask you is, why did you choose to use what is probably the most controversial and, quite frankly, in my opinion, the least likely to actually work in an overall integrated way as your definition of geoengineering? That's the first question. And then the second question is reflecting what we were chatting briefly about, and you just mentioned a minute ago, is this whole question of what kind of structures do you think should be set up to not to govern, well, in the end, to govern the use of this mechanism, but even along the way to, let's say, govern the use of the scientific experimentation in this approach, which, as soon as you start doing experiments of this type, you have a potentially negative or positive. You don't know. That's what you're trying to find out. So it needs some kind of oversight. So a quick answer to the first one and a longer answer to the second one is probably useful. Thank you.
And I should be done all that by about 10:30.
Yeah, well, that's what I thought. So I have to go before then. So
yeah. The first one is a good question. I think my view is that, so there are two things. Historically, geoengineering has more or less meant all the stuff that we don't like. So that the name has evolved over time since it was first used in the mid-'70s. And there are two broad sets of things that are now called geoengineering. The stuff I talked about, solar geoengineering, which has this, I think, is very much a whole. Like it or not, all the different ideas share a bunch of very strong commonality. They're all quick, they're all sort of fundamentally imperfect, they're all cheap, and they all involve very kind of similar science and similar distributions of risk. So I think there is a thing, like it or not, in solar geoengineering. Then there's a separate thing that's often called carbon geoengineering or carbon dioxide removal. I think there isn't in no way a similar thing. There isn't, in a sense, a there. There's an enormous range of things that people call carbon removal, right, including to CCS, which in fact most academics don't call carbon removal. They call it a way to cut emissions. But there it's disputed. And the things inside this carbon removal bucket vary enormously between things that really look like kind of conventional mitigation technology to things that look more manipulative. And they are not linked by similar policy considerations, very much anyway. They're not linked by similar science and engineering. So they're a very heterogeneous set. And it's almost impossible, I would submit, to say any non-trivial statement about geoengineering as a whole. I think there's almost nothing to say. They're just different. So the way I think about it, there are a variety of things we might do about climate change. We could just consume less. We could be more efficient about our consumption. We could decarbonize our energy supply. We could remove the carbon that's in the atmosphere. We could do solar geoengineering. We could adapt to change, or we could suffer. And those are a range of different response modes. And I don't think that carbon geoengineering and solar geoengineering are particularly more similar to each other than they are to any of the others, except they happen to be called geoengineering. And most of the formal sort of high-level panels that have worked on this, I've served on all of them, I think, have all effectively recommended separate them. So I think I don't agree with your view that most scientists would want to lump them. I think precisely the opposite. I think we've really had trouble by the lumping because, as I said, I challenge you to think of any non-trivial statement which is true about both. That's not a statement whether they're good or bad, they're just different. The other reason I think that I've ended up saying less about it is because I run that company, I've decided to do no academic work in that area to try and avoid conflict. So I just do the company. I love it. It's one of the more fun things I've ever done, but I then don't try not to talk much about that as I'll go to green tech conferences and talk as a company president just about how we want to succeed and make money, but I don't talk about it in these forums much. Your other question, short answer is read Parson and Keith. We had a nice short paper in Science trying to answer that question, and there are a variety of different ways that's being approached. maybe I'll say one thing. I think most experiments that I'm aware of, that people are talking about with any level of seriousness, including one that my colleague Jim Anderson and I and others at Harvard are working on, these experiments are process experiments which involve, they may or may not be good ideas, and there may be legitimate reasons to oppose them, but they involve extraordinarily small environmental perturbations. So the experiment called ScopeX that we're working on involves releasing roughly 1 kilogram of sulfur to look at the chemistry of the stratosphere. And there will be people who oppose it, I think, for legitimate reasons, but I think one reason is not that it's particularly risky in the global climate. It emits as much sulfur as 1 minute's flight of a conventional jet aircraft. And most other experiments that I'm aware of that people are considering are of a similar scale. I do think those things need governance, but I don't think the governance needs to involve kind of a global climate treaty because they're not affecting the global climate. And I think the single near-term thing we should do that I would like to work with you on in your capacity as president of ICSU is to help to get to a memorandum of understanding that's non-binding between some of the major science authorities that lays out some principles about transparency and a independent risk assessment and a kind of a means test, a usefulness test. And I think even something like that, say the Chinese Academy of Sciences and the US NSF did, would be very powerful in setting a standard for the world, even if it was not technically a binding legal document.
Okay, good, let's go over here.
Hi, so my name's Kai Remmer-Watts. I'm in the Master of Climate Change program that opened up at Waterloo. And I guess what your conversation brought to mind for me is when I think of climate change, I think of it kind of as like the icing on the cake in terms of just how unsustainable humanity's trajectory has become in relationship to what the natural world can actually provide. And while I see a lot of benefits to some of the solutions that you're suggesting in terms of actually providing a safe space, at least in the short term, I don't really see any of these solutions addressing more fundamental questions about things like resource consumption, depletion, which are ongoing issues that need to be addressed. So the possibility that climate change presents is the possibility for transformation. And I feel like some of these solutions really do just push off that transformation. So I guess my question is, the only way that I feel like I could be in any way comfortable with some of these proposals is if they were coupled with, much broader, more fundamental conversations about how we are going to kind of build a more sustainable relationship with the natural world. I mean, those are the conversations that need to be happening. And if all this does is push it off, I'm not really sure it's getting to the core.
That's a great question. I mean, that's sort of the perfect version of the Naomi Klein point of view. And let me try a few answers. So one answer is trying to agree with you. So I think the leading policy problem here is to think about specific ways to couple action to cut emissions on mitigation with decisions about SRM. So I agree with that. But then let me give you more of the disagreement. First of all, I don't think it's an objective fact that we have this kind of sustainability problem. I think we have many individual environmental problems that are very serious, but I'm comfortable using the word environmental problem because I think I understand what that is. Sustainability, especially the way you used it, talking about resources, sort of assumes that the problem is running out of resources in the way a lot of people thought we were doing for some period, especially in the 70s. And I don't see that as a substantial problem humanity faces. I do see problems of both environmental insults to ourselves, the 1 million people a year we kill with air pollution, as a serious problem. I do see direct environmental insults to the environment, like climate change, like land use, as real problems to solve. But those are environmental problems, and I kind of understand what they are. I don't really use the word sustainability because I've never understood what it meant. I think that it's possible that we'll solve this by a social transformation, but there are lots of other things, ways in which technology is driving social transformations. And I think that, in fact, the environmental things are small compared to the others. So the change in information and communication technologies, I think, is changing the world profoundly in ways that we are still only beginning to understand, the way that, say, democratic politics are changing. Look at the Middle East. We really cannot yet predict the way that will change, and that's only going to accelerate. We are looking at, increasingly intelligent machines. We already can see legged robots walking around on the Boston Dynamics website. They're going to be fighting through ruined cities in my lifetime, I believe. And I think that is one line. The other line is direct germline manipulation of humans. So when I think about the big ways in which technology are going to really affect society in this century, really change people a lot, I personally have grown up as a classic environmentalist, spent all my time working on environmental issues. This is what I work on. But I don't think those are going to be the big drivers that really shape it. And when you sort of say that the way we should solve this problem is by a social transformation, I guess I have two answers. One is a kind of a direct moral answer. So you kind of implied that something that just puts this off for 50 years really doesn't count. So I'm not quite sure I get what ethical frame you're coming from. I took philosophy partly as an undergraduate and read a fair amount of ethics literature, and I find it pretty hard to understand how you could justify discounting the direct impact and utility to people living now, kind of throwing that away and saying, delay doesn't matter, especially when you're mostly then talking about people who don't exist yet, who are just people who are going to be born. I just have trouble figuring that out in ethical systems that I understand. And finally, I think they're just a mismatch of timescales. Let me again sort of agree with you. So I do think that we are going to, and we have, I think, in societies like this, kind of reached some limits where there's a saturation of various objective measures of happiness versus consumption. So as people consume more, they don't get happier at this level of consumption. And I think we've biologically been shaped over our evolution to always want more stuff. And that maybe made sense in conditions of scarcity, but in the conditions that many of us in the rich world find ourselves in now, that wanting more stuff tends to not actually make us happier and just make us fatter. And so I think that we may need some social transformation to deal with this kind of post-scarcity society in the rich world, but I think that's inherently a slow thing. My mother and grandmother were both very active in outspoken in changing the role of women in our society, and you think about the pace of that change. I mean, this is something that goes back to the suffragettes and before, all the way through today's changes, and it's going to go on. It's not like these are very, very slow changes. Maybe we could have done it faster, but these are inherently slow changes. And I think the kinds of changes that really change the way people think about consumption and what the good life means are inherently slow changes. And I'm not against them. Indeed, I might actually agree with you. But I don't see why the fact that we might want to make those changes or need to make those changes in society as we see the disadvantages of kind of excessive consumption in any way alters the fact that I would also like to reduce climate change, and that given the time cost of the climate problem, I don't have time to wait for a technological change like that.
Well, and you seem to be fundamentally saying too that given the slowness of value and belief and cultural change, that allowing a climate crisis to occur with all the disutility and hardship it would produce is actually not going to speed up that change at all. It's rather pointless. This is something that's going to take place over a period of centuries.
A quick integration. Scott Barrett, a very thoughtful economist, political scientist at Columbia, has argued that climate change will make I think you would agree with him very much here, make a technological revolution one way or the other, either by producing some kind of global catastrophe that will force a technological change, or by forcing a technological change to avoid that catastrophe.
Right. But you're skeptical about the possibility of rapid value change. And I think that gets directly to this kind of comment, because if that rapid value change isn't possible, then it makes no sense to sort of say, well, bring the climate crisis on because it's going to finally force us to grow up as a species.
Yeah, I mean, if you strap me down on the couch, I guess I have both things. I actually work with people in the fossil fuel divestment movement at Harvard and MIT, and I spent now a lot of really fun time with young people who are really at sort of the cutting edge of the new kind of social movement to act on climate change. And when I spend time with them, I get excited about the possibility of rapid social change, at least in respect to kind of the politics around climate. But I guess when I step back, I still think it's going to be slow.
Yeah. Let's go over here.
Yep, from the
Your name,
figures.
your name, please?
I'm sorry, Terry Moran from Cambridge. the scheme you've outlined is very inexpensive to the point that there are individuals that could fund this, perhaps surreptitiously. Is there anything in place that could effectively halt that type of operation? I personally think it's inevitable that it will happen. I don't think it's inevitable that it will happen in a controlled manner.
Yep. So people talk, Dave Victor, another colleague of ours from the late 80s, has written about green finger, the idea that some ultra-wealthy person might just do this. I actually think that's not plausible or meaningful for the following reason. It's simply state power. So if some ultra-rich person decides to do this, even if the state that they're in lets them do it, other states will undoubtedly say, we regard the actions of this individual in your state as a state action. And in policy terms, it will be effectively a state action. So it will only happen because the state wants to allow it to happen, and other states will treat that state, if there's damages, as if it was a state action. So I don't really buy the idea that a private actor is going to have a big role in that way. That's if there's not, so that's, I heard the other part of your question. That's assuming that it can only be done in a way where you can see it's happening. If there is a surreptitious way to do it, which I think is hard but not impossible to imagine, then it's a very different game.
Yeah, apparently Operation Popeye, and during Vietnam, they were surreptitiously modifying the weather, and that wasn't detected for
so that's a good, so that's a very relevant story. So one of the very few treaties that are of relevance here is the NMOD Convention, the Convention on Hostile Use of Environmental Modification Techniques, which is entered into force as a UN convention. And the reason we have that convention was that the US attempted to do cloud seeding over the Ho Chi Minh Trail during the Vietnam War, and as a consequence of that act of using weather modification as a weapon of war, this treaty evolved. And I should say, a lot of people worry about possible use of this for war. And I do too, and I've written about it, in fact, back to the late 80s, written about it. But in the broad sweep, we're clearly moving away from that. So if you go back to the 60s and 60s, the leading, among the leading research foci of atmospheric science was weather control, partly for military reasons. And there was enormous focus in both the Soviet Union and America on weather control as sort of part of the Cold War. And first of all, weather control doesn't really work very well, if at all. And second of all, the whole field has just changed. So you just don't hear any serious talk about that now. So I think it's a risk to think about, but not one that's that prominent.
So let's extend the question a little bit in terms of the possibility of warfare between major states over something like this. And sometimes, for instance, scenarios are posited whereby a major state intervenes because they're being affected very severely by climate change, perhaps their food production, and they engage in geoengineering, and this actually produces, it's thought, significant weather modification in another area of the world, and that country is very unhappy. Do you think these things are potentially plausible further down the road? Yeah, I do. And it doesn't even have to, you don't actually even have to do the geoengineering to have it add to tension. Now, I don't think wars tend to arise, as you know better than me, for many causes. Mm-hmm. And so whether this would ever be a dominant cause, a little hard to believe, but could it contribute? Yes. So, for example, there's a scenario, a method of doing this that involves making clouds whiter, a certain kind of marine boundary layer cloud by spraying sea salt. It may or may not work. Let's say, well, China is seeing a decrease in its monsoon strength, and this apparently really concerns people right up to the Politburo. I have secondhand knowledge of this. And the Chinese governments have a habit of really caring about things that imperil food production in China. That's one of the few reasons Chinese governments have ever changed in history. And so let's say the Chinese take this seriously enough that they decide to try this, doing this, or even announce a program to get going on a campaign like this that would restore their monsoon strength by cooling off the
the South China Sea. And monsoons have to do with the contrast between the land and ocean temperatures. This isn't totally implausible. And let's say the Indians think it's correct, it hardly matters what the real truth is, that this will make their monsoon strength worse. What do we have then? We have two major powers already with tensions, both nuclear armed, who have some conflict over something that's really core to their state stability, because both of them, the issues of national food production are really high level issues that hardly need be said. So you can imagine scenarios where this contributes to tensions and lead to war. And to me, that's one of the reasons to start talking about this stuff early. Because at this point we have, not far from having a global treaty or effective governance mechanism, we have not even kind of a rough idea of what the right norm of behavior is to settle a dispute like that. And I think one of the reasons that we, in my opinion, should get talking about this technology, even if we don't use it, is because to avoid the chance of kind of making fast decisions in a crisis that really could result in the really horrific outcome, it's important to get political leaders and people who think about these systems and can develop ways to communicate clearly, talking about it early to avoid a kind of miscommunication disaster like that.
Great. Now we have a question on the screen, which is a very good one, which I would like to leave for the end, and two questioners over here who've been very patient. So why don't we go with these questions, and then we'll finish with the one on the screen. Okay.
I'm Robert Graham. I'm from Waterloo. And I'd like to question the objectives of geoengineering. Specifically, I'd like to know, is there an optimal climate? Is that optimal climate one that we have had in the past? Is it the climate that we've got now? Or is it something that we should strive for in the future? And if there is an optimal climate, is it dynamic or static over time?
So that's a great question. I think there's a sort of simple answer. There is no objective optimality. I mean, the value is inherently value-driven. There's no objective way to calculate what the right answer is. So the short answer is there isn't an optimal climate unless you say what your particular value is. So if all you care about was global primary productivity of crops, then maybe there's some kind of intermediate optimality. If all you care about is protecting people from tornadoes, maybe there's some other optimality. But depending on what you care about, you're going to have different answers for what's optimal. Not that you could even really get there very well anyway. So short answer is short answer is there isn't an optimum that's meaningful.
So what is the objective of geoengineering?
So what would you like it to be?
Pardon me?
What would you like it to be? I don't control this thing. I work on it. I am an innovator. I talk about it. But I have no more say in what the objective is, or at least should have no more than anybody else. I have things I might like to use it for, personally, that I would vote for, but I don't make decisions. And part of the whole thing I'm trying to communicate is there is no right answer to that, and people will have different answers.
So then, should we be doing things without an objective?
I can tell you what my objective would be for at least doing research, and if the research proves out going ahead. My objective would be to reduce the rate of climate change so that there's less changes in things I care about to do with the natural world and do with impacts on people in this generation and next.
I think we'll go on.
I'll leave it there.
Yeah. I think that's a great question. It gets to a core.
Hi, Sandra Moybrick of Waterloo. Thank you for your talk, and thank you that we could really have a conversation about how difficult it is to even frame the problem. So, the objectives and what's the problem and what do we do about it. A lot of the conversation in the last few years is we have to do something in a hurry. I get that sense, lots of conversation about the problem being the high level of, it's the rate of global climate change is what I'm hearing you say, but we've boiled that down to how much carbon dioxide we have in the atmosphere. And so if that is now the problem, and a potential solution that's being batted around seriously is putting a price on carbon, so that we have a carbon tax or some kind of a pricing mechanism, will that then inevitably lead to this kind of, it's an engineering solution now, and this is the cheapest and easiest way to do it, so will that then almost be inevitable if we frame the problem and talk about a blunt policy solution like that?
I'd say my sort of short answer would be no. That is, I can imagine having a carbon price or tax mechanism, which I really favor, as a way to have kind of get some of the politics out of choosing which energy solution we like and just kind of focus people and companies on finding cheap ways to cut carbon emissions. I could imagine that happening pretty independent from whatever decisions we make about this, because there's no way you kind of generate any market carbon credit out of this. So I see them as pretty different. I guess what you're implying, which might be correct, is that both of them represent a kind of technocratic way to think about the problem, and that that's different from a kind of social transformational way to think about the problem. But honestly, in some level, I don't know what it means to have because remember, if you want to stop emissions, you don't need to make a small cut. You need to bring emissions. If you need to stop the growth of CO2 concentrations, climate change, you need to stop bringing emissions to zero. And I don't think there's any social change other than to be glib about it, a mass suicide, that does that. So I think inevitably, a big part of this is going to be changing the way we make energy so we decouple energy from carbon emissions. And that, it takes social change to get us to do that. I mean, I think the idea of putting these two things in opposition kind of, in a way, throws away the key part of the problem. The key part of the problem is we need various social and governance changes to figure out how to implement the things we need to do to cut emissions. Indeed, you could argue that it's mostly social in that sense. We have lots of things around that could cut carbon emissions right now. Why are we not doing them? Because we haven't got a social organization capable of pulling it off. It's not as if we just need to innovate on that score.
So David, you and I have been talking off and on about these things for 25 years. And I'm wondering whether there's been real progress in the conversation in that period of time. I've noticed one very significant change listening to you today, which I would be interested to see if you think of the same thing. But there does seem to be a certain repetition of conversations we were having back in the late 1980s. Where do you think we've made advances in thinking about this issue?
Maybe we haven't. I mean, one answer is sort of a personal answer is I think these things happen generation by generation, and this is why I've had a lot of fun working with these 20-year-olds on climate policy. I think the honest truth is that though both of us have done lots of interesting things, you can see the way of our opinions have had a lot of consistency over 25 years, which isn't necessarily a good thing. Maybe it shows that we need the young generation to take over. So I'm not being totally glib about that. I guess I do think, I'll say this. There was a period about 10 or 15 years ago when I first came to Calgary where I was quite involved in Canadian climate politics, and I wasn't working significantly on this topic at all at that point. I had, but I wasn't. And I think there was a period where I really thought that just a little bit more pushing and convincing and we could actually get real climate policy to happen. And I still think that's possible, but I now think that it's harder than I did then. And partly I had a great fun last year teaching a course at the Kennedy School called What We Can Learn from the Failure of Climate Policy. And this gets a little bit to that last question I want to answer. We've had enormous success solving a lot of environmental problems since the Second World War, and essentially none on this problem. And I think that when you really think about that over the last 50 years, explanations for why we haven't solved this problem that are because I don't like that politician or this government are clearly insufficient because we kept rerunning the experiment and not getting anywhere. Yeah. So it isn't just because you don't like this current government. I mean, you may not like it or you may love it, but we tried this experiment in many countries with many governments, and we've made progress on a whole lot of environmental problems, but essentially none on this one. And I think as I've thought more about that, it's made me realize the kind of underlying reasons why it's hard to get action here.
Well, one thing I have noticed in your presentation today is a dramatic reduction in the projected annual cost for geoengineering. So I can remember a number of years ago, you were talking about, folks were saying, we can probably do this for $30 billion a year. And,
Yeah.
and even then you were thinking, wow, that's really cheap. But now you're talking about $1 billion a year, and that's just extraordinary.
I mean, that partly comes from the fact that I'm talking about a more gentle version of it, if you can call such a brutal thing gentle, but doing less of it. But also, simply we went to the engineers. We went to a big aerospace engineering consulting company and talked to several others and said, how hard is it to bring materials up to 20 kilometers altitude? And the basic answer was, from our point of view, this is more or less what they call commercial off the shelf. Take more or less conventional aircraft technology, do something a little bit different, and they kind of feel like they know the cost pretty well.
Yeah, and that changes the ballgame.
Yeah.
Let's get to the last question then. This is from Bill Bulmer in Kitchener, Ontario. I teach secondary school in town. Can you offer advice to teenagers who seem to have given up on the planet and its future?
So I love that question because I do talk to both my people in my kids' schools and to high schools and elementary schools occasionally. And I do think that we have got to a culture of too much defeatism on this score. I think that's partly because people who I work with, kind of the environmental activist community, have strategically decided to turn up the volume, to talk in more and more catastrophist terms, hoping that will incent action. I think it's not been a successful strategy, at least not so far. And I think we've underplayed all the successes. And I really think, and that's what in answer to this question and when I talk to students, I don't mean to Pollyanna. We do have big environmental problems. Climate is a huge one I've worked on my whole career. But we have, by citizens taking action, often starting with very small groups of people, had transformational change on a whole series of environmental challenges. And on each one, we had many of the same issues we have here, kind of entrenched interests and institutional stickiness and difficulty of arguments over the science. And so if you think about, photochemical smog, the kind of air pollution that essentially in the LA basin, this problem is not solved, but the problem is substantially better, even though we have far more cars on the road. So we made enormous success. Water pollution is substantially better in much of the rich world. Lead and other metals we substantially reduced. We made real progress on a whole series of environmental problems. DDT and these long-lived organochlorine pesticides, we haven't solved those problems, but made really dramatic progress in return after seeing problems. And it's just important to say that each of those things looked hard at the time, and if you go back and talk with people who were involved in those scientific and environmental battles, they often felt it was hopeless at the time, but real progress got made. And we have, as a society, figured out, without totally changing democracy, we've actually managed to make progress on all these problems in a pretty dramatic way. And it's important to say that. And that was, all of them were a combination of social change, some of the environmental consciousness that grew in the 60s, and technological change coupled together, and coupled with innovations about how to, for example, make cars have much less pollutants. Not carbon, obviously, but other pollutants were greatly reduced by innovation, some of them, very effectively using market mechanisms and private innovators, but spurred on by government regulations. And so I just think it's important to say how much we've won. And that doesn't even talk about the way that in, say, the former Soviet Union and East Bloc, which had just hideous environmental records, individual citizens, even starting back to before the fall of the Soviet Union, in fact, arguably coupled to its fall in some ways, fought environmental destruction and have made substantial improvements. And it really is important to tell that story. And China right now is waking up to this fact. China has installed more sulfur scrubbing capacity on its power plants than the entire capacity we have. And in lots of other ways, China's beginning to take seriously environmental regulation. Is it as fast as I want? No. But it's important not to throw up one's hands and give up, and to think about the many ways in which there's really been successes, because I think in the end you can only motivate people to really do something new by telling a story a true story that has some sense that success is possible. And I think overstating the story that it's all doom and gloom makes people just tune out and give up. And so I think some warranted optimism and historically founded optimism is a really, really important part of this story.
Well, thank you. And that's a terrific way to end. And I think Fred is going to come up. Are you closing the session this evening? But I do want to say before Fred comes up that David has a book. Were you going to mention the book? On climate engineering that's just been published. This is, in fact, a quasi-book tour The Case for Climate Engineering from MIT Press. Are there any copies available?
Somebody can turn the, if you want advertising, switch the screen back.
Fred, are there any copies of the book available this evening? Here? But in any case, if you want to learn more, I'd strongly recommend you purchase a copy of the book. David, thank you very much for not only just walking us through some of the subtleties and complexities of this story, but really showing your deeply ethical sensibility for the issue, which I think has been really refreshing for people here. So thank you very much.
Thank you very much.
Well, I'm here to give a vote of thanks on all our behalves to, to both of you. First of all, to Tad for bringing David Keith to Waterloo, helping to invite him up here, and for so elegantly moderating the discussion tonight. And then especially to our featured speaker for your remarks. I think you challenged us to think about geoengineering as a response to the climate change problem, not on the basis of fear of technology or other emotional responses, and not as some sort of a demonized foil to other desirable social goals like good transit, and not as a panacea to the problem either, and not as an excuse for other policy failures on emissions, but rather in the light of evidence and scientific research and thoughtfulness and clear thinking. That's a point of view that's always welcome in a research community like this one, and I think we all appreciate your remarks and your visit here, so thank you very much. Just a quick note, the edited video of this evening's live webcast will be posted to the CIGI website, and a blog will be posted. You can put your comments on the blog. A note about our next public events here in the CIGI auditorium. On Wednesday, January 29th, CIGI welcomes Senior Fellow John Ibbotson, who will speak on the Harper Doctrine, a conservative revolution in Canadian foreign policy. John is on a one-year leave from his position as Chief Political Writer at the Globe and Mail, and he's conducting research for CIGI on Canadian foreign policy. And on Wednesday, February 12th, we welcome T.V. Paul to the CIGI stage to discuss Pakistan in the contemporary world. Dr. Paul is at McGill University, where he teaches international relations and has written several books on security in South Asia. So be sure to register for these events and for our events newsletter, and have a safe journey home. Thank you again.
Also of order trillion a year class if you want to actually decarbonize the economy by mid-century. So $1 billion a year is effectively zero. That's not a statement that it's necessarily the right thing to do, nor, and this is crucial, that it's a substitute for cutting emissions. So I'll say this several times during the talk because I don't want any of you to walk out thinking that I've said something different on this topic. In the long run, if you do not stop emitting carbon dioxide, you bring this climate further and further away from the stable or the metastable equilibrium that we had when humans first started to mess with it, and there is no way that any amount of solar geoengineering will fix that problem. So this is something that may reduce the risk, may very effectively reduce the risk, but with bringing itself lots of new risks in its train over the next, say, half century or century, but it does not perfectly substitute for cutting emissions. I mean, I guess to be glib, sulfur is not anti-CO2. It doesn't cancel out all the amount of CO2 that's accumulated since the Industrial Revolution. You know, you can get carried away by the technological sleekness of this. So this is a picture of what one of those aircraft might look like, but underneath kind of sleek stuff and a kind of technocratic excitement about this, let's be clear, this is a very ugly technical fix. We're talking about putting a pollutant, arguably in the stratosphere, one that would no doubt kill people on the ground from adding to fine particulate air pollution. The net effect, I think, would be very positive. That's what most models say, though it's not certain. But this is something that would be messing with the planet at a very large scale. We're adding essentially one pollutant to partially compensate away the bad effects of another. So that's the kind of scheme we're talking about. There's several other schemes, but that's the core of it. And the questions that are really hard are all about how well it works, what the risks are, and most of all about who decides and how we decide to do it, or even to research it. One last comment before I get into the details. This is not a new idea. So this may be new to some of you. I'm one of the people who's been talking about it most prominently for a while, but this idea is absolutely not new. The very first major report on climate change that had all the science right, as we now understand it, that got to a world leader, got to President Johnson's desk when I was 2 years old, 1965. And it's actually worth reading that report because it's really nice and short. And now we have the IPCC report, which is this thick. I've been a member of the IPCC, but quit because it was too boring. It's a bureaucratic organization that produces these monsters. And the reports to Johnson, and if you look at the other reports, like the Energy and Climate Change report produced in the late 70s, they're gems of succinct, effective science policy analysis. And in that report to Johnson in 65, that was the beginning of really articulating the climate problem correctly to a world leader, saying that if we keep burning fossil fuels and putting CO2 in the atmosphere forever, we're going to have a very different climate. That report, as its sole suggested solution, had a version of this. If you did that, this is what the plot of climate change would look like. So the x-axis here is this watts per square meter. Don't worry about what that means if you're not familiar with it, but just think about the x-axis basically being increasing climate risk. Basically, the x-axis has to do with the amount of CO2 that's accumulated in the atmosphere, and accumulation is the issue. The climate risk that we have this year, which we do have, doesn't come from the emissions this year. It comes from the emissions since the Industrial Revolution. We're adding, fluid to a bucket, and it's building up. And when you stop emitting, all you do is stop adding to the problem. You don't make it go away. So this curve is what happens to the risk if you do this curve above. So you basically stop yourself adding to the problem, and then the risk stays about where it was for a while. That might be the right answer. There's no simple answer about what the right answer is, but that's one thing we could do. But it's important to say, because we're going to now talk about the technical fix, that this technical fix is not on top of doing nothing. This technical fix is on top of, in the example I'm going to give to you, really aggressive actions to cut emissions. And the point is, even under those aggressive actions, you're going to have pretty substantial climate change by the end of this century and even more the next. So let's say you do some solar geoengineering. There are various ways you could frame it, but I think it's important to think about it as something that's fundamentally temporary. I don't think you do it forever. You do it as a way to reduce the rate of climate change, to spread the climate change over a longer amount of time, because there is abundant evidence that a big chunk of the risk of climate change comes not from the absolute amount of change, but comes from the rate of change. And so we could use this technology with all its attendant risks potentially to reduce that rate of change. So if you did solar geoengineering along a trajectory like I've shown in red here, you'd start maybe in 2020, that was my first scenario, you'd build it up gradually to 2100 or something, and then you gradually ramp it back down to zero. And so the net effect of the climate risk and climate so-called radiative forcing would be what I've shown in orange there. So that's one scenario. But let's not fall into some kind of technocratic planner's dream. The reality is all sorts of things are uncertain here. It's uncertain how different nation states would act. It's uncertain what nature would do. It's uncertain what new things we find out. So one of the things that people worry about most in this business is that suddenly we'll stop. So that we sort of build ourselves this risk by committing ourselves to keep doing solar geoengineering once we've started. And I think some element of that is correct. So if you did it, in this case I've drawn it till 27.5, and then you suddenly stopped because there was a global war, because people forgot how to somehow keep the planes flying, because we found some particular risk of the geoengineering we didn't know about, that the particles we were putting in the air, caused some unexpected cancer or some really unexpected side effects, so we decide to stop suddenly. If you decide to stop suddenly, the climate warms suddenly. You reveal all the sort of latent warming that was there, and the impacts of that could be big. Of course, that's just one scenario. I'm going to throw more of these out there. Maybe what you do if you're a better manager is, so this idea is anything but new. And it was brought up in all the major reports in the 70s and 80s on climate change, but then it became taboo to talk about. As climate became a more potent political issue, many people on the advocacy side and on the science side felt that if they talked about this, people would lose the will to cut emissions. That basically by proposing this cheap, imperfect Band-Aid, that the ability to negotiate a deal to cut emissions would be lost, and therefore there was a kind of tacit agreement not to talk about it. Not a secret conspiracy pact, but just a kind of agreement not to deal with it. And only in the last 5 or 8 years has this suddenly come to the fore again. So The next set of slides I've given you are deliberately hand-drawn, both because my computer was stolen out of my house this weekend, but also because I want to emphasize, it's true, because I want to emphasize there's a lot of uncertainty here. And the hand-drawnness of some of this hopefully doesn't fool you by a beautiful computer model, which I'll show you at the end, that this is all precise. We're talking about the future of the world here, and the uncertainties are very large. So first, let's talk about carbon emissions. Don't worry about the units much, but the units on the y-axis there, gigatons a year, is the amount of carbon we're emitting. And while that's a hand sketch, it's roughly right. And the red line is the track we're on now, with very rapidly increasing carbon emissions globally. And that's not a lot of tragedy. That's partly because 100 billion people in China have lifted themselves out of poverty. But the consequences are this massive movement of carbon from deep underground to the atmosphere. Humanity is a geological force on the planet now because of that. And a geological force that dwarfs every other part of the carbon cycle. An obvious question you should have is to think, how big is our effect on carbon compared to nature? And the answer is the natural process that moves carbon from deep underground and puts it in the atmosphere is degassing of the crust through volcanoes, and we're like 100 times bigger. We're not a little perturbation on nature, we're 100 times bigger. That's why we're changing the climate at this extraordinary pace. So let's say we had a clean, green revolution. I'm including nuclear power, whatever. Let's say we have a combination of a policy revolution, because we're not close to that right now, and we actually manage to decarbonize the world's energy system pretty fast. And actually, that's pretty fast, that blue line, so that we bring emissions effectively to zero at the end of the century, and we peak them just before 2050. That is not an easy thing to do. That's sort of an aggressive strategy by the standards of people who analyze this. Let's say we do that. What does it do to the problem? Your natural assumption is kind of solving the problem. And for lots of pollutants, that would be true. So air pollution kills about 1 million or 2 million people globally, a lot from putting sulfur in the atmosphere. And if you stopped all emissions of that sulfur globally, the people would stop dying a few days later, because sulfur only lasts in the atmosphere for a few days. But carbon is not like that. Carbon lasts in the atmosphere like nuclear waste, millennia. So this is something that would result in Frankenplanet. It is certainly not, though, a single unitary solution. There is no such thing as a single solution to a problem as complex as this. So let me start with this very, very narrow version of what one of the things one could do, one of the most plausible. So suppose you wanted to cut the rate of climate change in half, starting in, say, 2020. It turns out that on a technical basis, it is pretty clear that that is doable. And I'll say a little bit about how you could do it. So one of the most plausible ways is to put sulfuric acid droplets in the stratosphere. And what do those things do? They reflect away sunlight just the way droplets of water in clouds reflect away sunlight. Indeed, a droplet of water in the stratosphere would reflect away sunlight fine. The reason for the sulfuric acid is because the stratosphere is very dry, and if you put a water droplet, it would just evaporate. The other reason that people think about sulfuric acid is nature does this. There is already a lot of sulfur in the stratosphere, and big volcanoes occasionally put very large amounts of sulfur in the stratosphere and cool the planet down quite dramatically. That happened last in the early 90s with the eruption of the Pinatubo volcano. So to be really specific on a goal, and there's no right answer to what the goal is. There are some right and wrong answers about the science. I can tell you with some confidence if you do A, then B will happen. But the question of what the goal of such a program ought to be is fundamentally shaped by values and judgments and so on. So I'm not claiming this is the right answer. It's, to me, just a plausible answer. And it's a lot better than some really nutty answers that seem to be part of the mainstream debate. We'll get to that. So I'm saying the goal might be to cut the growth of radiative forcing, which is a big fancy word, which roughly means the amount that we're sort of pushing the climate, which has to do with the amount of carbon dioxide that's accumulated in the atmosphere. You could cut that in half starting in 2050, starting in 2020. And doing that is frighteningly cheap. You could start in 2020 with roughly 2 or 3 aircraft. Re-Engine Gulfstream G650s, for those of you who like aircraft, there's lots of other things you could use, but we paid a big aerospace engineering firm to actually do a study, and that was one of the answers they came up with. And you'd start putting sulfuric acid in the stratosphere, and if you kept doing this all the way until, say, 2070, cutting the rate of climate change in half, and therefore cutting most climate impacts in half over that entire chunk of time, by the end you'd have maybe 50 aircraft or something. You'd be spending something like $1 billion a year, which might sound like a lot of money, but it's effectively zero when it comes to decisions about global climate. The costs of climate impacts, from everything from lost crop yields, from high temperatures that reduce the growth of crops during high temperature during germination, for example, or sea level rise or what have you, the estimated global costs of climate change mid-century are of order 1% of global GDP, so trillion-dollar numbers. And the costs of decarbonizing the economy, the costs of cutting emissions by switching to solar or nuclear or wind power, those costs are all.
Good evening, ladies and gentlemen. Welcome to the Center for International Governance Innovation, or CIGI as we say. My name is Fred Kuntz. I'm the Vice President of Public Affairs here at CIGI. I'd like to thank our public event sponsor, Wordsworth Books, for their ongoing support of our signature lecture series. Thanks also to those joining us from around the world through our live webcast. Following this evening's address, we welcome questions from both audiences at the microphones here at CIGI and through the live chat function if you're watching on your screen at home. Please remember to state your name and to keep the questions brief. The topic of tonight's lecture is climate geoengineering. And what is climate geoengineering? Is it the solution to climate change, the techno fix? Is it conservation ecology or the creation of a new Frankenclimate or playing God? As the title of the address is the case for geoengineering, no doubt our speaker has a view he'd like us to share. David Keith comes to us from the Harvard Kennedy School, where he's a professor of public policy, as well as a Gordon McKay Professor of Applied Physics in the School of Engineering and Applied Sciences. He's Canadian-born. During his 25-year career, he's contributed to research on climate-related technology assessment and policy analysis, technology development physics, and atmospheric science. And these contributions have received recognition and even accolades from the Canadian Geographical Society, the City of Calgary, the Massachusetts Institute of Technology, Time Magazine, and the Canadian Association of Physicists. David currently splits his time between Cambridge, Massachusetts, and Calgary, where he's executive chairman of Carbon Engineering, a private company that proposes to capture CO2 from the air. And following the lecture tonight, David will be joined in a conversation on stage by Thomas Homer Dixon, CIGI Chair of Global Systems and Professor at the BSIA through the University of Waterloo. Thomas, better known to us as TAD, has recently been investigating societal innovation in response to economic, technological, and ecological change, and TAD will be facilitating this evening's discussion. So please join me in now welcoming Dr. David Keith.
Thank you very much. It's terrific to be here. I'm going to move this talk from starting in the most sort of specific, technocratic, kind of ugly way, giving you a specific idea about what we might actually do. And then move from there to talk more about what I think of it, what other people think of it, what enormous challenges it raises for global governance, what questions it raises for humanity's interaction with the natural world. Just before that, I'd say that, kind of in answer to some of those implicit questions at the beginning, in some ways I think the answer is all of the above.